For this problem, we're going to graph two functions and find their intersection points. Given that f of x equals x squared plus 3x and g of x equals 5x plus 3, we're going to solve the equation f of x equals g of x. We're going to graph each function and label the intersection points. We're going to solve f of x equals g of x, which means we need x squared plus 3x to equal 5x plus 3. We want to move everything to the left side by subtracting 5x and subtracting 3 from both sides. So we'll have x squared. If I subtract 5x, we'll get 3x minus 5x, which is negative 2x. If we subtract 3 from both sides, we'll have minus 3, and that all equals 0. We have a quadratic equation. We can solve this by factoring. We'll factor the left side as x minus 3 times x plus 1 equal to 0. We'll set each linear factor equal to 0. So x minus 3 equals 0, x plus 1 equals 0. And we solve these two linear equations. The first, we'll add 3 to both sides, get x is equal to 3. And the second, we subtract 1, so we'll have x equals negative 1. So f of x equals g of x when x equals 3 or x equals negative 1. We're going to need the intersection points, which is an x and a y. To find the y values, we can take each of these x values, plug it into either one of our two functions, since we're looking for the point where the two graphs cross. We're going to use the simpler function g of x to do this. So we'll find g of 3. That's 5 times 3 plus 3. This gives us 15 plus 3, which is 18. And g of negative 1 is 5 times negative 1 plus 3, which is negative 5 plus 3, or negative 2. So the intersection points will be 3, 18, and negative 1, negative 2. We should verify that these are the same points that we would get if we had used f of x. And we could try one of the points just to show that this is actually the case by letting x equal negative 1 in f of x. We'd have negative 1 squared, which is positive 1. 3 times negative 1 is negative 3, and 1 minus 3 is negative 2. So that point checks. And we could also check this point 3, 18 as well. I'm going to go ahead and graph each function now. We want to graph f of x equals x squared plus 3x, and g of x equals 5x plus 3. To graph the function, we could do this by plotting points, pick some values for x, plug them into the function, and get points on our graph, and then connect the dots. For f of x, we might pick values, say negative 5. If we put in negative 5, f of x is equal to 10. If we put in negative 3, f of x is equal to 0. If we put in 0, f of x is equal to 0. And if we put in, let's say, positive 3, f of x will be 18. We can go ahead and plot these points. 1, 2, 3, 4, 5. At negative 5, we look at our scale. The scale on the y-axis is by 3s. So we need to be careful when we go up to 10. And our scale along the x-axis is just 1. So we go 1, 2, 3, 4, 5. That's negative 5. We go 3, 6, 9. So this would be our point, negative 5, 10. Plot the point negative 3, 0. 1, 2, 3, 0. Point 0, 0 is the origin. And then the point 3, 18. You get 3, 3, 6, 9, 12, 15, 18. We'll go ahead and connect these dots. Recognizing that f of x is a quadratic, so the graph is a parabola. We get our rough graph of f of x. G of x is a linear equation. So we have a linear function here. The y-intercept is 3. And plot that. And we can pick one other point. Say x is equal to 3. If x is 3, g is 18. So we'll connect these 2 points. And that's the graph of g of x. Now we've said that our two intersection points are 3, 18 and -1, -2. We have the point 3, 18 marked already. That's one intersection point. The other intersection points -1, -2, which would be around here. And since we were drawing a rough graph of f, we see they're not quite hitting where they're supposed to, but it's pretty close. This point, -1, -2, is the intersection point, so the graph should both go through that point. So the graph of f of x and g of x intersect at 3, 18 and -1, -2, and we have a rough graph of both our functions.